So I see it is 10 o'clock. Welcome everybody. This is our winter weather webinar. Ryan Ellis is our Science Operations Officer. Some of you should start to get to know him a little bit. He started last fall, but again, with us being mainly virtual, this is the best way for you to meet him. We still hope to schedule some one-on-ones with you probably after the holidays so we can at least try to meet face-to-face. Continue to let us know about any meetings you have. I know in Onslow County, we're usually there once a month for the McTIFR, and they're doing that virtually. So if you're having some local LEPC meetings or anything where we can join or where we would have joined in person, let us know about that, and we'll still do that virtually. So Ryan will get started. Ryan's going to present at the end some what makes winter weather forecasting challenging. I'll do kind of the overview, the first half of the presentation. We're going to go over Winter Weather Preparedness Week. The reason why we scheduled it this week is because starting yesterday, it is Preparedness Week for North Carolina. We're going to talk a little bit about spotter classes. We're going to go over the winter outlook. What does an outlook mean and what does it mean for us this year? Then a new product that the Weather Service has been working on for many years, and now it's kind of being spread across the country. It's called the Winter Storm Severity Index. We're going to talk about how that could be useful for us this winter if we do have any storms. The snow forecast, kind of a refresher. We've been doing this for multiple years, but we're going to go over the most likely forecast, the worst case, and how to access that information. And then one of the biggest challenges for forecasting is winter weather, and Ryan's going to do a presentation on that at the end. Just some housekeeping. You should be able to hear me just fine and see us. If you have any trouble, again, we're going to record this so you can view it on YouTube afterwards. By doing the audio this way, you don't have to worry about background noise. At the very end, we'll take any questions. If you want to verbally talk to us, just raise your hand. We'll unmute your microphone, and then we can converse that way. At any point, you can ask us questions through the chat. Very, very easy. If you're doing this on a computer, it's pretty easy. And you can also download the app on your phone. Very, very easy to ask questions and also to view it. One thing that now that we're becoming a little bit more familiar with the software, we uploaded this presentation and some helpful links. I've got links to our snow map, WSSI, all the information you need. So you don't really need to jot any of this down. With that helpful links PDF, you should be able to get that. And that'll be under the handout section of your tab. So on this far right, you should see something that says handouts. Click on that and you can download the presentation along with those links. As we mentioned at the top, Winter Weather Preparedness Week started yesterday. That's why we scheduled this webinar to coincide with that. You'll notice in our hurricane season, we always say it takes just one storm, and that's not a company line. That is the truth. It only takes one snow or ice event this winter to cause an issue. You're going to see that the official forecast is for an above normal winter. Doesn't mean we can't have one snowstorm. So the time to think about preparedness is now. We have an awesome website, lots of new information. The Weather Service has gotten really good with some of these infographics. This is information you can use on your website or social media today. Now, understanding that it's Preparedness Week, a lot of people don't really get into the winter preparedness or tropical preparedness until the storm is on the horizon. Let's face it, we're not thinking about it, even if we talk about it, until we actually see it in the forecast. So please bookmark this website and leave it, and I'll try to re-add it to the helpful links. I think this might be one I forgot about, but bookmark this website. These graphics can be used beyond just this week. For example, if we have an ice storm, this is the type of graphic you'll want to share on social media. And if you have PIOs in your county, this is the type of information you don't want to have to recreate. Just use our information and share it, and you'll be good to go. Most of you should be familiar with our website. The two things I want to mention about this, our briefings are awesome. You share them, you can post them at the EOC. They're very useful. We get a lot of good feedback on them. But we update them twice a day. Our website, we update every 3 hours. And if you want to know certain criteria for winds or snow, or when does the temperature actually fall below freezing for a winter weather event, I highly recommend you use our weather graph, hourly weather graph. If you just scroll to the bottom of the screen, there's a hourly weather graph, or anytime you click on a forecast, scroll down and on the lower right is an hourly weather graph. It's great information, hour by hour, out to 7 days. Other thing I want to mention is if you have any search and rescue or any hazardous incidents, we do have a spot weather forecast. I can provide that link to you. You can get specialized forecasts for those types of things as well. And by all means, you can always call us if you have a question on the forecast. Last thing I want to go over before we start to get into the crux of the presentation are weather briefings. You should be familiar with this, and most of you should be on the briefing list. If you're not, or if you want to pass this information on to others, if they go to our website and scroll to the bottom under weather hazard briefing, that will be a direct link to the briefings themselves. And a reminder, we only send these out when there's really bad weather headed our way. So it's not a daily or weekly update that we send out. Social media is something we've been on for a long time. This is what we really use to cut through the noise, and we make these shareable, concise information, one graphic, so you can just share it on your pages as well. The one addition this year, you'll notice the Instagram icon. We became a test office for Instagram about a month ago, so we are on Instagram. All of them, you can just follow us by searching NWS for National Weather Service, Morehead City. So that's kind of the introduction. Our website, briefings, what you should be familiar with. But I really want to emphasize, again, that webpage for preparedness. Yes, use it this week, but don't forget about it January or February when we have a storm and you want folks to remember how to drive in the ice, how to prepare for being without power, that types of things. Lots of information on that page. So now we're going to talk about the winter outlook. And before we do that, any type of seasonal or climate forecast or week forecast, we want to go over what it means. The Climate Prediction Center does a seasonal outlook, winter, spring, summer, and fall, but they also do a 6 to 10 and 8 to 14 day outlook. And they're very similar to this in terms of how they divide it up. With this forecast, it's broken into thirds, either below normal, equal chances, or above normal. That should be equal chances, not near normal on the slide. And what that means is they, based on predictions, climate patterns, some long-range signals like La Nina and El Nino, they will see how strong the signal is and assign, equal chances, below normal or above normal to the forecast. I want you to, unless it's a really high percentage, some of these forecasts aren't as useful in certain years if the signals aren't strong. So this is our winter outlook for this year. We'll get into our area in a second, but on this one, anywhere shaded in this orange color is a better chance that it'll be above normal. Anybody shaded in this blue color is a better chance that it'll be below normal. A couple of things to show you on this map. It's a 68% chance of being above normal in South Texas. Anytime you see really high percentages, these forecasts, 6 to 10, 8 to 14, and seasonal are useful. Anytime you start to have these lighter shades of color or the equal chances, that just means that there's not a super strong signal. It's not a really strong El Nino or La Nina or something that we can sink our teeth into. And so there's equal chances of it being below, near, or above average. So keep that in mind when you look at these. Really try to focus on the percentages, and unless they're super high, they may not add a lot of value to the forecast. Here's some examples of that. This is a forecast for this year for northern North Dakota. It's for a below normal year. From the pie chart, you can see it's a 46% chance it's going to be below normal. From that pie, again, it's divided into thirds. Since we think it's going to be below normal up there, we take a little bit of the pie away from the above normal section. So you see that that percentage is down to 21. It doesn't mean that they can't have an above normal winter, but when you add the near normal and below normal, it's a 67% chance they're going to be, a normal winter for them or even a little colder than average. So a couple things to point out on that. You can see that even with the predicted below normal winter, they still have a 21% chance it's going to be above. Not a big chance, but it's still a chance there that could happen. I want to show you another example. This is our official forecast for the Carolinas, a 45% chance of above normal temperatures this winter. But again, since we're predicting above normal, that pie shrinks in the below normal category down to 21 or 22%. So you could say, it's favored to be above normal, or at the very least, it's pretty unlikely based on what we're seeing that we're going to have a below normal winter, 22% chance at that. That's probably one of the hardest things to mention to you or to predict. Climate forecasts are very, very challenging, not only to forecast, but also to understand. This is our official winter outlook without the percentages. Again, above normal temperatures are favored. It doesn't mean that we can't have periods of cold snow or ice. And we were kind of talking in the office, the last week to 10 days, I think is a pretty good snapshot for our winter forecast if it works out. On the whole, December, January, and February, when you just look at the numbers, it is favored to be above normal in terms of temperatures. However, have we had a cold spell? Are we chilly and kind of nasty today? Yes. So we'll still have chances for snow and ice. And just a reminder, again, it only takes one event. As far as the winter outlook, again, it's divided again the same, below normal, equal chances, or above normal for precipitation. So these darker colors right here are the stronger signals. That's where our highest confidence would be. Here toward the middle, not a lot of confidence because we kind of could go either way. We're kind of on the edge of that, just a slight favoring of drier than normal conditions. Even if that forecast works out, again, a reminder that it just takes one event. You can still have some rainy periods, you can still have flooding, and so please keep that in mind. So that's the winter outlook for this year, favoring above normal temperatures and below normal for precipitation. Want to shift gears now to our SKYWARN classes. Traditionally, SKYWARN has been in the spring and summer, hail, high winds, tornadoes. For a couple years now, we've been trying to make a 24/7 year-round spotter program, and we've done that a couple different ways. One is have a variety of classes. So these winter classes are going to focus on who we are, why we need spotters, and how you can call in snow and ice information. We offer a tropical class as well. All this information is on our website. You can see that the schedule is right here, but there's a tab called recorded training. So if you want to look back at our spring or tropical training, you can certainly do that. I just emailed this out, and I just wanted to remind you folks, each year for Storm Ready, it's every 3 years that we certify you, but that's one of the hardest parts. We'll go over that preparedness section. What type of outreach have you done? Since we're in a virtual environment, it's limited. So I'm really looking forward to counties helping to host these classes. Since they're virtual, it doesn't mean you need a location. We're not coming out to you. What you'll do is you'll say, hey, Eric, we would like to host a class in, Onslow, Jones County, Craven County on the 16th. All you have to do is promote it on your website and social media. If Jones, Lenore, and Craven all want to do the 16th, no problem. But when we go through your Storm Ready applications and we're looking to renew it, we'll use those to say, hey, yes, you did help with the SKYWARN. And that's how we're going to do it this year since it's virtually. If you've got any questions, please let me know. The reason why I'm hammering home the spotter classes, we really need those reports. It's not just us, it's DOT, historians looking back at the storm, planning purposes. We all use this data. It really helps us in the decision process. Plotted on this map are all the airports we have in Eastern North Carolina. So you might say, wow, we have a lot of observations. These are temperature, wind speed, dew point, great stuff. But only 2 locations report climate information to us in terms of snowfall, New Bern and Hatteras. So there's a lot of gaps in here, even amongst the airports, but it's certainly when you're talking about snow measurements, we're not getting them from the airports. So we heavily rely on our spotters. Contrast that with this map. These are all our most recent spotters. Again, much larger coverage than we have with airports. But you'll see, southern portions or near Beaufort and southern Washington County, Terrell County, there's certain gaps where we don't have spotters or observers. So please help us promote this information. And one really cool class, in the class itself, we mentioned a program called Coco Raws. We try to encourage people to join that because it becomes a daily effort. And then that way they're used to calling in or submitting their reports. It's not like a once or twice a year type of thing. So recruiting is year round. We really appreciate if you can help us get this word out. Unless you tell the community, the only advertisement we have is our social media and website. So again, help us be the megaphone for the entire community. So we talked a little bit about the Weather Service, went over the outlook, talked about spotter classes. 2 more things I'm going to talk about, and then we're going to turn it over to Ryan. The first one is WSSI. So what that is, it's a new product. You can see on the right, it has different winter storm impacts. It's the Winter Storm Severity Index. The whole idea is to look at all different components with winter weather and to summarize it in one graphic, or if you want to look at it separately. So we look at things like snow amount, snow load, how wet or heavy the snow is, blowing snow, so the combination of snow itself and wind speed, a ground blizzard, which is just fallen snow that has already occurred on the ground, it's being blown around, a flash freeze where you have rapidly falling temperatures, and ice accumulation. The thing that we find most useful from this product so far is a lot of our focus is on how much snow you get, and people think those are the highest impacts. Some cases that's true, but what if we only have 3 or 4 inches of snow inland, but right along Highway 17 is a major ice storm? Graphics like this will help not viewers, but the general public and yourself, how to kind of understand what some of the impacts are and where they're going to occur. Apologize, this map itself is a little blurry, and we're going to go over it one by one to help show you. This upper right is the total WSSI for a storm back in 2019 in the Northeast. We're not going to pay attention to that yet. We're going to go slide by slide on the bottom, starting with the lower left. So in this example, this is the snow amount. Again, red is major, orange is moderate. So from this forecast, you can see they're expecting a lot of snow. This is Western Massachusetts, Southern Vermont, East Central New York. So lots and lots of snow. On a traditional map, that would show perhaps feet of snow up in that area. Where WSSI can separate hazards is by showing how some of the other components may affect you. So the second image is the snow load. And notice the red area has shifted east. This is right along the rain snow line or the wintry mix line. And that's where we expect it to snow. The amounts may be less, but the snow is really, really heavy. So we may have power outages and issues with folks having power and communication. Then this last graphic on the lower right is ice accumulation. So just to the south and east of the wintry mix line, you may not be concerned with heavy snow, you're concerned with ice accumulation. Still, power outages, but also issues on the roads with ice accretion. So this WSSI can show you, who's going to have the heaviest snow, the far left, who's going to have the potential for wet snow, the middle of this graphic, and who's going to have an issue with wintry mix or ice, the southeast part of this graphic. So you can break it up amongst components, or you can view it as a total aggregate of itself. So the total is the upper right. So here's our heavy snow for the Northwest, our heavy snow amounts. The middle are the heavy wet snow clinging to everything, and this little strip of red just south of Boston is where we expect the ice. I looked for a more current example, and the one from this past week didn't have ice in it, so it didn't articulate what we wanted to show you. Where can you find this information? First and foremost, if we think it's going to tell a good story or emphasize a point that we have, you're going to see it in our briefings. So especially if we have ice, if we have heavy wet snow, or if we think those maps highlight part of the population and tells a good story, we're going to show it. So you may see it in our briefings. If you want to check it out today, again, this is included in your helpful links document. The website is on the top, but that'll be in that document I shared. It defaults to the continental United States. At the top under this Zoom area, you can change it to a local forecast office. So if you scroll down to MHX, you'll just get our forecast itself. They have the day 1, 2, and 3, and then you can do day 1 through 3, kind of the total of what will be the worst case of all of them. If you have a GIS expert or you like Google Earth, you can download these as KML and shape files as well. So if you have some GIS people, you can download that. And we're always looking for feedback. So on this website, I think there's a section for feedback. Please provide that. We'll see. If we get winter weather this year, you may see us use that. So a couple more slides on our forecasts, and we're going to turn it over to Mr. Ryan to talk about how hard winter forecasting can be. For most of you, this should be a review. This is our website, weather.gov, and if /moreheadcity. If you scroll to the bottom, there's a winter weather page. This is where our snow forecasts are. Our official snow forecast is what we expect to happen. This is the most likely scenario. Those will be included in the briefings. A couple other graphics on that website is a worst case scenario, a 1 in 10 chance. We like to use this, especially if it's showing some areas that we're uncertain about in terms of amount. So we'll contrast this. This is the storm last winter, 4 to 6 inches across the north and west part of our area, 1 to 2 down here toward the coast. But by looking at the worst case scenario, I can tell Jen in Carteret County and Norman and Onslow, hey, even your worst case is 2 to 3. So the chances for you to have heavier snow are not likely. But just north of Stanley, up toward Pitt County, Samuel up in Lenoir County, Greenville up in Pitt County itself, those are the areas. If we're going to have more snow, if we're going to have some bands of heavier snow, that's where it's going to happen. So again, we'll use this in our briefings if we think it helps make the message concise, especially for planning purposes of where amounts may be on the, we might be off and have some slightly higher amounts. Also on that website, I really want you to get in the habit of scrolling down. Your eye is drawn to the snowfall amount and worst case scenario, but scroll down. There's a lot of good information on this page. I was going to do it interactive, but I just wanted to load it up for you. There's graphics that show the chance of snow above 1/10, an inch, 2, 4, 6, 8, 12, or 18. So as you hover above these graphics, percentages will change. In this case, 3% chance of a teensy little bit of snow. And this is actually from yesterday's forecast. I know we could have some flakes later today, but not expected to amount to anything. But this shows you if you have certain thresholds, hey, I'm concerned with an inch, you can have, or greater than an inch, you can have exact percentages for your county. If you like to see it on a map, you can do it that way. If you would rather have specifics for the town, scroll down and you can change your county to whatever county you represent. So in this case, we did Carteret, so we can see Beaufort, Broad Creek, Morehead City, Newport. It has the expected snow, what we think is going to happen, worst case, least case, and then again the percentages for more than a certain threshold. I think you may be familiar with that. If you want more explanation, we made a video probably about 2 years ago, and that is in your helpful links section as well on our YouTube page. Great information if you like probabilities and predictions of snow. So at this point, we're going to segue over to Ryan. While we're doing that segue, again, if you have any questions, you probably have my email. If not, Ryan's email is on there as well. So I'm going to go ahead and make him the presenter. So it should be yours here in a second. But feel free to email us. And as we mentioned, if you have any questions about this presentation, please put it in the chat. Ryan and I will get to those at the end. If you're just joining us, again, this is going to be recorded so you can view it on YouTube. So you're looking good, Ryan. I see your slide. I'm going to hop out and then turn it over to you.
All right, that sounds good. For those of you on the call who haven't met me, my name is Ryan Ellis. I'm the Science and Operations Officer here at the Weather Service in Morehead City. I've actually been here for over a year now. Came down about October last year. Got to meet some of you in those first couple months, but obviously since then we haven't been able to get out as much as we would like to. So one of the things I wanted to do here today, my job as a Science and Operations Officer is a little bit more internal. And so I work with the forecasters a lot, making sure operations is running smoothly, digging into some local research and things like that to help bring some of those newer ideas into our forecasting to make sure we're all up to date. And one of the interesting things is that as we get into winter here, there are so many more variables that we have to forecast than normal. And so what I wanted to do today was kind of pull back the curtain a little bit on what we kind of deal with as forecasters and putting it in a format that is as easy to understand as possible. So the first thing I like to say, this is kind of what I call the Murphy's Law of forecasting, is that the harder the forecast is to make, the more accurate people need it to be. And so let me give you a little example here. In the summertime, we might get a question, something like this, very simple. Am I going to get some sun today? We want to go fishing. And yes, we are very confident that we can give you a confident answer to that on most days. Now, when things change in the wintertime, we get questions that are phrased more like this. Facebook told me it's going to snow 14 days from now. How much snow am I going to get in my backyard from 4:42 a.m. to 7:18 a.m. and will school be closed? Oh, and by the way, will it be enough to build a snowman? Will it pack well? If not, my son will be upset and this whole thing won't be worth it and it'll be all your fault. So as you can see, we definitely get interesting things. And in some form, I've kind of concocted them all together, but in some form, I've heard all of those in my career, going back about 10 years or so. So this presents a problem for us in many ways. And so I want to kind of remind people what the different types of precipitation that we're forecasting and what it takes to get those. So first and foremost, we've got one of the easier ones, which is rain. If our freezing level is high enough, we're going to have a lot of warm air below, and anything that's frozen is going to melt and come to the surface as rain. And then you have freezing rain, and that's this one here, where you can see we have a layer of cold air above, some warm air getting into the middle, and then as we get down, there's another layer of cold air beneath. But it's not that deep. And so what's happening here is you might get snow forming up top. It melts as it goes through the warm air, comes to the ground as rain, but then the ground is so cold that it freezes on the ground. And so that's freezing rain. Sleet, on the other hand, is going through a thinner layer of warm air, but it's enough that it actually melts the snow. But before it hits the ground, it actually refreezes. It has enough time to refreeze and hits the ground as ice pellets or sleet. And then finally, we have snow, which is, of course, starting out as snow. It's cold all the way through the atmosphere. And as you get to the surface, it's still falling as snow. Now, a lot of places, whether you're in the upper Midwest or up in New England, interior portions, sometimes you get a lot more of that cold atmosphere, and so it's easier to tell. When you're down here in eastern North Carolina, we have to deal with the Atlantic Ocean being right next to us, and a lot of times that'll moderate the air, make it a little bit warmer, and change some of these characteristics in the middle. So what do we do? How do we get to this point to forecast this stuff? Well, as you know, we look at models, weather models. So what actually is a weather forecast model? What does that look like? And so this is a good graphic I found that basically shows you that a weather forecast model is a series of grid points that goes across the entire globe. And there's points on the surface, and then there are points aloft. So these gray boxes are points in the atmosphere where the model is trying to give us, at each one of these points, it's trying to give us temperature, dew point, relative humidity, any kind of moisture values or things to tell what kind of precipitation we might get. So all of those things have to happen at each of these grid points. Now, if we were to want a perfect forecast over the entire globe, we would need all of these grid points and everything in between to be perfect. So I'm pretty confident in saying that in my lifetime, we're never going to get a perfect global forecast, but there are things we can do to get closer. So the first thing we have to consider is that computer power is finite. We only have so much of it. So as we go out in time with these forecasts, we have to kind of make choices about how we're going to run these models. So if our grid points are further apart, we can run the model further out in time because we're using less space on the computer. But at the same time, we're getting bigger and bigger gaps between our points. And so the model has to kind of fill in those gaps with what it thinks it's going to happen there. And so as we get closer and closer to the storm, we're not going out as far in time, so we can make these grid points smaller and smaller and smaller, get more data to actually see what's going on. So, and as this is going on, we all know that when we have some things going on with Facebook algorithms and things like that. So if we have a 14-day forecast that says there's going to be a foot of snow, everybody's going to share that, and they're going to share it early. And so that the more it's shared, the more it keeps compounding on itself. So when the update comes in showing that we may only be getting 6 inches of snow, everybody that's out on Facebook is still seeing that foot of snow and sharing it and sharing it and sharing it. So you as a user can kind of help us out by making sure we're looking at the sources we're using, what is the timestamp on there, so that we know when this forecast was made, to make sure we're looking at the most recent data. So if we break this down even simpler, it might look something like this. This would be temperature. And so you can think of each one of those numbers as one of those grid points on the previous slide. And so what you're seeing here is there is a body of water, and there are temperatures at each of these boxes. So how does the model actually try to do this? And what I'm going to do here now is I'm going to try to demonstrate, and I'm going to pull out of the presentation mode a minute here so I can use this. Okay, good. We can still see that. So this would be, for instance, all of those grid boxes that you saw, and simply along the bottom here is the ground, and then going up in the atmosphere as we go up in the boxes. So this is a summertime example of what a model might do. Okay, and so when we ask that question, you know, what is the temperature going to be in the summer, I might get a model that's giving me temperatures at the surface of 70 degrees over here and 80 degrees over here. But right in the middle is where we want to know the forecast. So if there's no data at that point, the model is probably going to interpolate between the two and give you something like 75, which is in the summertime is fine. You know, the difference between 70 and 75 degrees, it's debatable if we even know what that feels like in the human body. And so, you know, there's not a lot of consequence to getting that temperature wrong. And as we go up in the atmosphere, maybe 65 degrees here, maybe 55 degrees here. Okay, so none of those are below freezing, and so we're pretty confident that as whatever falls out of the sky falls, it's going to be rain all the way down. So now let's go to the winter, and now we're 14 days out, so we're very far away from the storm, and we might get a model that comes in, and our grid points are further apart now. And so we have 20 degrees over here to the west, 40 degrees over here to the east. It might tell us that at the surface here, we might get 30 degrees, okay? So that would tell us that we might get some form of freezing precipitation. But what if the next update comes in? Now, we've already shown probably at this point a forecast on Facebook where this model told us that it was going to snow and it's going to be crazy, and people are already in sharing mode. And so, but then the next forecast comes in and we've got a little bit more data with it. And so now we might have something where we have 36 degrees over here and 38 degrees over here. So what this is telling us is that, maybe our cold front isn't arriving as quickly on the surface. And so we actually have a temperature of 37 with this forecast cycle, which actually tells us that now we're probably going to have non-freezing precipitation here. And so compared to the last model, which showed us below freezing temperatures, now that we've added more data to the model, we can see a little bit more detail. But again, on Facebook, we've already shared a foot of snow everywhere. Now, in addition to get the surface right, in the wintertime, you also have to get the vertical right too, because snow forms in a layer that's between -10 and -20 degrees Celsius, and in Fahrenheit, that's about 4 to 14, 4 degrees above or 14 degrees above to 4 degrees below. So you not only have to get the surface right here, but we have to get all the temperatures aloft right as well. So maybe we got a 20 here, and maybe we have, you know, something like a -5 up in here. So we can make that red. Okay. But now, remember we talked about this slide here with the warm layer coming through the middle. We're probably going to have a warm layer somewhere in here. So I might get snow falling down through this 20-degree layer, but now I might have something that looks like this, where it's 38 degrees here and 25 degrees here. So as it's falling through this warm layer, and now I have to determine if it's sleet or freezing rain. And so that's the basics of how the model works. You have these grid points, and we're trying to fill in as many of these spaces as we can. But in addition to trying to get all the ones on the surface right, we have to get all the ones up in the atmosphere right. And so to do that, we need a lot of observations. And while Eric showed a lot of the airport observations and things like that, we have a lot of stuff on the surface, but it's harder to get observations up in the atmosphere. We have weather balloons, we have satellites, we have things like that. But all of these have their problems. And so these are all the things we're looking at and more. So some of these considerations, you know, how many miles are between each of these grid points in both the horizontal and the vertical? What are the time stamps we need? Is the model too fast or too slow? You know, are there timing errors with it? Is the freezing level where it's supposed to be? Is the snow layer where it's supposed to be? Where are some of these warm layers? So there are all these things that we have to try to look at. And so the bottom line here, as we go back to presentation mode, is to help me help you. So winter forecasting is hard. We know this. Check reliable sources and make sure when you're sharing those sources that you're taking a look at that timestamp, seeing when that forecast was put out, and trying to help us control that message of what the latest forecast is. Understand how those social media platforms work. Each one is different, and as we're getting more social media platforms out there, it is important to understand how they work, how things are being shared. Is it a popularity thing? Is it chronological? You know, what is the algorithm being used by social media? And finally, nobody wants to get this right more than we do. I mean, we always hear things, you know, it must be great to be paid to be wrong, things like that. But nobody wants to get this right more than we do. And it's a big challenge. But as we move forward with technological advances, these models are getting better. Some of the things that go into them, I gave you a very small sample of, you know, how one little portion of that model might work, but there are so many other things that go into it. And also helping us out by telling us your thresholds and what are the decisions that you are making. Because if we know what those thresholds are, we can help you to distill out some of the more pertinent information that you need, and we can get that into our briefings. And so it's a great way to help us connect with you, and also to make sure that we're getting you the data and the information that you need. So that's all I had. Eric, I'll throw it back to you for some final thoughts.
All right, Ryan, thank you very much. And hopefully from that you can see how you know, just a little difference here or there can make all the difference in the world for forecasting. And unlike this, you know, people know when we forecast sun and rain happens, but they don't seem to get quite as upset as if we get the snowfall amounts incorrect. So Ryan, I don't see any questions in the chat. So while we wait for some to come in, my screen should be up. I just want to show you a live example of the website, the winter page. Again, if you scroll to the bottom and click on the winter weather tab, that will send you over to this. Again, our official forecast, but it's interesting. Might be a few wet flakes later today and tonight, not a big deal. In a worst case scenario, we've got a light little coating up across the northwest part of our area, but you can see in our expected, what we expect, we don't expect that to happen. But to show you how the table can be useful, if you scroll down, these are those percentages and thresholds I was talking about. So for percent chance of more than a tenth, just a 13% chance up toward Williamston. I don't think Jody's on the call, but I'll pick on Martin County anyway, and no chance of more than an inch. So you can kind of see your thresholds there. And if we scroll down to the table, again, I'm picking on Martin County because that was, you can change it to whatever you want. I could do Beaufort, but it was 0. So I changed it to Martin County, and you can see that we don't expect any snow. Worst case would be less than an inch, and you can see from that it was mainly a tenth. And look at all these 0 percentages for an inch, greater than 2, 3, or 4, 6, 8. But here's your percentages of just a light coating. Places like Everett, Gold Point, Hamilton. So up in that northwest part of the county, really from Williamston north and west. But often we can't show you anything live because we don't have snow in the forecast, but since we did with this, may as well show it to you live. So I don't see any